Okay, we learned something last time called Coulomb's law, and we measured the electrostatic force that exists between any two charges. And Coulomb's law was F is equal to K Q1 Q2 over R squared. So if we knew the masses and we knew the distance between them, we could calculate the electrostatic force that exists between them. So what we're going to do today is, what if there's more than one charge? What if there's 3 charges? What if there's 4 charges? So that's why we're going to apply something called the superposition principle. So basically it says when you have more than one charge, you find each individual force that exists, and then you find the resultant. Now, we've actually done this before, because remember, a force is a force, okay? So forces are vector quantities. They have both magnitude and direction. And it just is more tedious than anything else, but it's very simple. You've done it before, and we can do it again. So we're just going to do electrostatic forces. We're going to have more than one force, and then we find the resultant. Now, originally, when I worked out the homework, I worked it out step by step, but I remember then after that, we ended up, when we had several forces, when we found the components, we did a table. And I think a lot of you were able to understand a little bit more easy with the table. So I'm going to work today's homework a little bit differently using the table. So let's just go do an overview first. So we have to find the resultant. So the net electric force on a charge, so again, we're still using Coulomb's law because we're talking about the electric force on a charge due to 2 or more charges, is the vector sum. Again, forces are vector quantities. So when I want to find the net force, I find all the other little individual forces and I add them up. So just to go over vector addition, because this is what we did before, if I have 2 forces and I want to add them up, what I'm going to do is, and I'll do this in table form, what I'll do is I'll find all the x components. So if I have 2 forces, F1x and F2x, that'll give me the resultant of all the x's. Then I'll add up all the y's, and then what happens is, remember, once I have Fx, which is really the total, and Fy, which is the total, to find the resultant F, what I do is I add them head to tail. So this would be Fx. From the head of that vector, I do the tail of the other, which would be Fy. Then when I want to find the resultant, from where I started to where I end up is my resultant F. But remember, vectors have both magnitude and direction. So now to measure the direction, I always measure the direction from the tail of the resultant. So tangent is going to be opposite over adjacent, so that's why it's F of y over F. So we've done this before, okay? We're just applying it to electrostatic charges, the forces, and we're going to do the same thing we did before. So the net force on the charge due to more than one charge is the vector sum of the force due to the individual charges. Use 2 subscripts, because we're going to have forces 1, 2, 3, 4, and then we're going to have, now when I say 2 subscripts like this, so this F12, this is going to represent the force on charge 1 due to charge 2. So we'll have like F12, F13, it depends on how many forces. So here's our problem-solving strategy. So what I did is actually did step by step. So when you're doing tonight's homework, you can refer back to this. You're going to draw your picture. I can't work a problem unless I have a picture. Because remember, vectors have both magnitude and direction. And I need to draw a picture of which direction the force is acting. Why? Because of my sign convention. Is it positive or negative? So we have to establish our sign convention. Draw all the forces acting on one charge with the direction. Calculate each force using Coulomb's law. So what happens is I might end up using Coulomb's law 2, 3, 4 times, depending upon how many charges there are. Then I'm going to find the resultant. So I'm going to take all the x's and all the y's, and we're going to do it in a chart to make it easier. Then to find the total, I use the Pythagorean theorem and then definition of tangent. And this is an example in your book. Now, the example in the book I'm not going to work through. I'm going to work part of one of your homework problems. but I just want to show you the picture. So do you see here that I have 1, 2, 3 charges? Okay. So in this one, it says the cinema screen installed at the Science Park. So it says, find the magnitude and direction of the resultant electric force on Q1. So here's Q1. So what I'm going to do is I want to find the net force here. So there's an electric force between Q1 and Q3. And then there's an electric force between Q1 and Q2. Okay? Now, you notice that, first of all, the forces, this was F12 and this is F13. Which direction these go in make a huge difference. How do I know? Well, this is positive and this is positive. Like charges, they repel one another. Okay? So because these two repel one another, it's going to point away from Q3. If this was a force of attraction, it would go towards Q3. But because they're the same and we know like charges repel one another, it's pointing away. Then these two charges, see how this is negative and this is positive? So unlike charges, they attract one another. So this force is pointing here because it's a force of attraction. If they were not the same, it would be going in the opposite direction. So this is why it's important to first draw your diagram like this, because you need to know the directions. Once I do this, it's quite simple.
Please excuse the interruption. Teachers, at this time, please refer to the SELA list that was attached to your email. If you have any students that are on that list and need to take the SELA test, please send them to...
So then after this is the most important part of the problem. Then we just do Coulomb's law, we find the forces, we find the x and the y, and we put it together in a table, just like we did earlier in the year. So your diagram's important. And that's it.